welcome everyone to our webinar this morning. Firstly, just before we jump into the webinar itself, I'd just like to mention that we are recording today's session. This will then be posted onto the Lethe project website. So if there are any issues, then please just reach out to us in the chat. Welcome to the first in this series of webinars for the Lethe project and carried out by the Lethe project team. The aim of this webinar series is really to showcase the results of the project so far and also to look at the results from different aspects from within the project. We also aim to generate a discussion in the field with like-minded colleagues and also establish links to other ongoing initiatives and projects that tackle the same topic. It's my pleasure to be moderating today's webinar. My name is John Switters. I am a Senior Research Associate and Project Coordinator at the Lisbon Council, which is a think tank and policy network based in Brussels. So let's just have a little look at what we have planned today. So as you can see, we have quite an action-packed hour this morning. So from 10:30 to 11, we'll be having some short presentations from myself and my colleagues. I'll be kicking things off, just talking about trying to set the scene a little, talking about the approach we're using in the Lethe project. Then my colleague Vasilis will come in and discuss how we're capturing patient data through applications in the project. Hannes will then step up and talk about the Lethe App, the clinical trial monitoring system that we're using, and risk profile. And then last but not least, we have Nacho, who will be talking about using the EGI Fedcloud for the Lethe infrastructure. Then from 11 till 11:15, we have a couple of questions lined up for our speakers. So we'll have a kind of a short discussion about different aspects. And then we'd like to hand over to you and ask you if you have any questions for our speakers. If you do have some questions, please write them in the chat and then we'll address them during this section of the webinar. So my job, as well as moderating today, is to give you a brief, kind of set the scene a little bit for the webinar itself and give you a brief introduction to the project and the approach we're using. So I think before we jump into the different presentations, it's very good to give you or provide you with a little bit of context, especially for those of you who aren't working on the project, as to what we're actually trying to do. And I think we really need to focus on the issue we're trying to tackle. So dementia is the most severe expression of cognitive impairment, and it affects 55 million people worldwide. There are almost 10 million new cases each year. And dementia is currently the 7th leading cause of death and one of the major causes of disability and dependence amongst older adults. And these are statistics from the World Health Organization. And also, I think it's important to highlight the fact that it's actually a growing issue. So with the growing world population, there's obviously an increase also in dementia cases. And for a long time, it was thought that dementia was neither preventable nor treatable. However, whilst the causes are perhaps not curable, we do know today that the course of the disease might be modifiable with good preventative actions at an early time point. So let's have a look at the Lethe project. What are we trying to do, or what are we doing to try and help respond and contribute to help tackle this global health issue? So the main focus of the Lethe project is on prevention in the entire spectrum of cognitive decline amongst the older adults at risk. And to do this, we are developing a data-driven risk factor prediction model for older individuals at risk of cognitive decline, novel digital biomarkers for the early detection of the risk factors, and a digitally enabled intervention for cognitive decline based on the evolution of the finger study, which was a successful protocol to prevent cognitive impairment and disability that was actually carried out in Finland. Some basic data about the project, some basic facts about the Lethe project. It's actually one of the last standing Horizon EU-funded projects under the Horizon 2020 framework. It has a budget of 6 million euros and a duration of 48 months, although we've gone slightly over that now, primarily due to the restrictions that we faced during the period of the COVID pandemic. There are 15 partners from 9 different countries. So now we've kind of given an introduction to the project. What are some of the objectives? What do we aim to achieve? So we aim to achieve personalized intervention through predictive modeling. We also want to improve health literacy and empowerment by really including the person in the process and providing them with information and control over the disease onset. Another objective is data-driven health behavioral change through the use of sensors and innovative interaction technologies to generate data and also collect health biomarkers. We also want to improve disease knowledge and symptom interpretation. And to do this, we want to support healthcare workers to use data visualization to understand the importance and the impact of individual risk factors related to cognitive decline and dementia. We'll also carry out a simulation-driven improvement of personalized health and care pathways to improve care quality. And finally, we want to validate this approach, the Lethe approach, through the measurement of socio-economic effects and also the quality of life of persons at risk. So I think, although my colleagues will be perhaps going into more detail about this in their presentations, I think I just want to bring this up and highlight it at the beginning of the webinar today, that we should really highlight this central aspect to the project, which is the intervention study. And this is a 2-year study, and it involves 160 participants in 4 clinical centers in Austria, Italy, Sweden, and Finland. And as you will see, we're collecting a lot of data in this project. And to do that, we'll be using various different tools, such as the Clinical Trial Management System, or CTMS, the Lethe App, cognitive games such as C-Train, and other devices such as Fitbit. And on your screen now, on the right-hand side, you can see screenshots from the Lethe. And then finally, you provide participants with different interaction technologies to track data and also to receive personalized suggestions for brain health. And this will be carried out through 2 separate sub-studies, one featuring the very futuristic looking here Temi robot on your screens, and then another using the smart glasses, which you can also see on the right-hand side of your screens. So that's it from me. I hope I've managed to just set the scene for you and also set up my colleagues who will now follow me. So without further ado, I would like to invite Vasilis Loukas to the floor. Welcome, Vasilis. And Vasilis will be talking about capturing data patient data through applications. So please take it away.
Thanks a lot, John. I hope you hear me. So, hi, good morning, everybody. Initially, I would like to thank you for joining this webinar series. My name is Vasilis Loukas, and as part of the fourth team, our work in the Lethe project focuses on integrating and managing the flow of data collected from multiple sources, ensuring that this data is securely processed and used to build effective and accurate predictive models for cognitive health. Today, I will walk you through how we collect and manage patient data, the types of data collected, and how these contribute to personalized interventions. So let's begin by looking, John, if you could swap the slide.
This one, Vasilis?
I think he's having connection problems.
Me?
No, John.
Yeah, I think so.
Vasilis, can you hear me?
Yeah. Could you please swap the slide?
Yeah, of course.
Yeah, thank you.
Vasilis, can you see it now?
No.
Really?
Your connection is unstable.
Yeah. Yeah. No.
Yeah.
So, let's begin by having a look at the overall architecture of the Lethe platform. And yeah, this one, bro. Yeah, okay. So let's begin by looking at the overall architecture of the Lethe platform. The system has been designed to support real-time data collection, secure storage, and AI-driven predictive models for personalized intervention and visualization. Here is the overall view of the platform. The sensing ecosystem comes at first, and this component is the starting point where all data generation happens. We use wearable devices like Fitbit and the Lethe mobile app with integrated cognitive training and the Radar passive app to gather data from study participants. This data is collected in near real time and includes a wide range of information such as physical activity, cognitive function, sleep patterns, and cardiovascular metrics. Then comes the data lake, which from the sensing ecosystem, all collected data is centered. At this stage, the data is organized and prepared for transmission to the data warehouse, structuring it accordingly to predefined formats. The data warehouse stores the structured data and makes it available for more complex processing. This is where we can apply advanced queries to extract specific insights and merge data from different sources. Our AI core module is responsible for predictive modeling, which is key to the platform's value. Using the prospective data collected during the trial, we train machine learning models that help predict cognitive decline, adherence to lifestyle intervention, and so on. Finally, the results and insights are delivered to clinicians and some of those to patients through dashboards, integrating also smart glasses or social robots. Can we change the slide, John? Thank you. Now let's have a look at the types of data collected, which have been defined based on state-of-the-art literature and consultations with clinical experts specializing in dementia prevention and treatment. We collect data from several physical domains. Physical activity. Data on physical activity is collected using Fitbit devices, including metrics like step count, time spent in different activity intensities, and calories burned. Physical activity is measured both actively and passively. App usage and phone integration. Through the Radar-based passive app, we collect data on phone usage, such as how often the phone is picked up and how long it's used, what applications are being used. We use CCOG and CTrain applications to gather data on various cognitive tasks, such as memory recall, reaction time, and problem-solving abilities. These apps present tasks that challenge different aspects of cognition, providing a detailed look at cognitive function over time. Heart rate variability, and sleep data are collected from Fitbit wearables as well as smoking habits. These metrics help us assess the overall cardiovascular health of participants. Participants also report their nutritional intake via the Lethe App. We track food choices and alcohol consumption, as diet and lifestyle factors are known to affect cognitive health, particularly in older adults. All these variables are continuously monitored, allowing us to build a comprehensive picture of each participant's health. Then, on the next slide, we're going to have a look at the weekly score and feedback notifications. And this is essentially the way that we keep our patients motivated and engaged through the weekly score and the feedback notification system that we have built. Each week, the participants receive a score based on their adherence to the intervention protocol. And these scores are categorized into 3 paths: green for excellent adherence, yellow for moderate adherence, and red for low adherence. This feedback is crucial because it helps patients understand how well they are doing and where they might need to improve. For example, when a patient's score improves, they receive motivational messages. Importantly, the thresholds and algorithms for these feedback paths have been defined by clinical experts. Technically, the system uses a service architecture with each component executing on a different day of the week. This ensures that the feedback is timely and personalized. Finally, we're going to have a look in the weekly aggregation and weekly data aggregation and comparison. And this is a system which powers the feedback and scoring system. The data aggregation process works through an automated pipeline. Each service in the pipeline is responsible for querying, processing, and aggregating specific types of data from the data warehouse. For example, on Mondays, the system queries the data on physical activity for the past 3 weeks. On Wednesdays, it queries cognitive training results. The aggregation process combines current data with past trends to identify whether the patient is improving or declining in different lifestyle categories. This allows us to deliver personalized feedback. The system, in a technical perspective, is implemented as a collection of services orchestrated using Apache Airflow and Docker. And this system allows us to scale, this setup allows us to scale the system easily and ensures that even more, as even more patients enter the study, the system remains efficient and reliable. In conclusion, the Lethe platform collects and processes a vast range of data across multiple domains: physical, cognitive, behavioral, and cardiovascular. By using state-of-the-art technologies for secure data storage and personalized intervention, we aim to significantly reduce the risk of cognitive decline in older adults. Our platform not only collects data, but also uses it in a meaningful way to motivate patients and provide real-time feedback, ensuring that the interventions are active and are effective. So this is all. Thank you for your attention, and later on I'll be happy to take up any questions.
Thank you very much, Vasilis, and apologies for the slight technical issue there during your presentation. We'll come back to you during the panel discussion with some questions.
Sure.
But now I would like to call upon Hans Hilberger, who will be giving a presentation about the Lethe app, the clinical trial monitoring system, and also the risk profile. So please take it away, Hans.
Yeah, thank you very much, John. So my name is Hannes Hilberger, and I'm a researcher at the University of Applied Sciences in Graz in Austria. And today I'm honored to present to you the applications we have developed in the Lethe project, so the Lethe app and the Lethe clinical trial management system and its integrated risk profile, where I am the lead developer. And before going deeper into the applications, I want to reprise some key facts about the project. So around 45% of all dementia cases are attributed to 14 modifiable risk factors. And in the Lethe project, we recognize the importance of those modifiable risk factors and are targeting to prevent cognitive decline in at-risk elderly individuals. And for that purpose, we conduct a 2-year-long intervention in 4 different clinical centers with 160 study participants. So in Austria, Finland, Sweden, and Italy. And each study participant gets a mobile application, so the so-called Lethe app, which should support them throughout the study. On the other hand, the health professionals have access to a web application called the Lethe CTMS, where they can monitor the participants' progress. And with all the data we are collecting through the mobile app, the CTMS, and Fitbit, we want to predict the risk and the progression of cognitive decline and visualize it in a risk profile, with which I conclude my presentation at the end. So first, we have to have a quick look at the intervention itself. If you go to the next slide, John, please. So we have identified the modifiable risk factors and grouped them into several lifestyle domains, namely nutrition, cardiovascular risk factor management, cognitive training, physical activity sessions, social activity, and sleep and relaxation. And at the clinical centers, we have various in-person activities. But for the Lethe app, we've developed for each lifestyle domain a digital counterpart, like questionnaires, a diary, or videos. But we also incorporate multi-domain activities, which are personal goals, tiny habits, and educational resources. And if you take a closer look at the app, on the next slide, we see the Lethe Lifestyle Program, which incorporates all the activities which I've showed you on the previous slide. And on the other hand, we have the personalized activities. So these are individual for each participant. The personal goals are set together with the health professionals, and tiny habits can be chosen through a big library, which are also mapped to an intervention domain. You can think of tiny habits like lifestyle recommendation turned into easy to follow habits. For example, preparing the meal the night before. So that is the Lethe app, and because there are so vast functionalities, I've created a video series. You can scan the QR code on the top right, where you can see all the functionalities, and there is also a quick tutorial on how to use the app. So we can also see here the questionnaires, the calendar, the videos, and the educational resources. So that is the point of view from the study participants. And now we are going to the CTMS, so the point of view of the health professionals. And here you can you go one back, please? Yeah, so here you can see the list of all the participants which are in the study. Here now, for obvious reasons, we only have the test participants, but on the left, you can also choose between the participants of the different clinical centers. And the last two buttons below the countries are for changing the content in the app. So for example, you can change the videos or change the educational content in the app. So every clinical center is also independent and can use their own resources there. If we look at a detailed view of a participant, you can see how many questionnaires they've finished or what questionnaires they do not finish. You can track the personal goals if they are fulfilling it, but you can also book appointments directly in the Lethe app for each participant individually. And yeah, now I've talked extensively, or we have talked extensively about all the data collection. And now coming back to the what we want to achieve, so predicting the risk and the progression of cognitive decline. And for that purpose, we utilize the so-called SHOP framework in order to provide an explanation for a prediction. So as you can see here in the risk profile page of the CTMS, we have either a high or a low risk patient, meaning a high risk for cognitive decline or a low risk for cognitive decline. And we have also grouped them again, the variables used for the machine learning model, into those lifestyle domains. So here you can see cognition, diet, physical activity, and so on. And everything that is blue contributes to a low risk of cognitive decline, and everything that is red contributes to a high risk of cognitive decline. If over 50% are blue, then that means it is overall a low risk. And if more than the half of the circle is red, then it is a high risk of cognitive decline. You can also click on you can click also on a domain and can see each variable, how it contributes to a high or to a low risk. And what is interesting about the risk profile itself is on the left side, where you can see all the variables used for the models. Then you can also change, for example, a variable, for example, the body mass index, click on simulate, and then a new prediction is made. So here you can also, in the future, plan the intervention for each participant individually by simulating different pathways and to get the participant to a overall low risk of developing cognitive decline. So thank you for your attention. And I'm happy to answer all your questions afterwards in the discussion. Thank you.
Thank you so much, Hannes. That's great. And we'll definitely come back to you in the panel discussion for some questions. I'd also like to encourage our audience members to ask any questions they may have in the chat function, and we'll address those in then the audience participation section at the end of this webinar. So without further ado, let's move on with our last presentation this morning from my colleague Ignacio Lamata Martinez. Please take it away, Ignacio. And Ignacio will be talking about how we are using the EGI Fedcloud for the Lethe infrastructure in the project.
I think this is the first time someone pronounces my name perfectly. Really, it's the first time that happens. So, okay.
I think
so
that's
my
20 years in Spain.
Yeah. Peace out. So my name is Ignacio Lamata Martinez, and I work for the community support team of EGI. And I'm going to introduce today to you to the infrastructure that we created using EGI Fedcloud to support the Lethe project. So please, next one. So, okay, this is an overview of the project, but I think you have already some overview of it, so we can skip this slide. Okay, so we start by the hardware requirements. So as you know, and my colleagues have presented, we divided the system into different components. So, for example, we have the EcoSense that Vasilis talked about before, that is in charge of collecting all this data coming from Fitbit and other wearables. And for the EcoSense, we have here represented the structure that we use, and it's based on these three machines that are configured in a Kubernetes cluster. So probably this language is a bit technical, but basically what we do is we allocated some virtual servers, some machines, some computers to run the application. And we configure that in using an application called Kubernetes that is managing let's say the programs that run on these computers. And also you can see that we have allocated a hard drive of 1 terabyte. This is what it means, the 1000 sign over there, and it's encrypted. So that's why there is a lock on this icon. Apart from the EcoSense, you can see the rest of the components. So we have the data lake, we have the data warehouse, a dashboard, aggregation, and some others. We have also a monitor or a monitoring system that is in charge of checking that the rest of the components are alive. And if something happens, it will notify us that something is wrong, so we need to pay attention to something. And we also have a backup system that is also in charge of collecting data to have a double, let's say, backup of the data that we use. You can see there the requirements that we use. So we have 16 virtual machines, 89 CPUs, 234 gigabytes of RAM, 18 volumes, more than 12 terabytes, and so on and so forth. So next slide, please. So here I will present how we use the EGI Fedcloud, or all the services that we have available in EGI support this project. And I listed them here. So basically the EGI Cloud Computing used to provide the servers, the machines that run applications. EGI Check-in is the solution we use for authentication and authorization of users, and also for communication between components. EGI Online Storage is for the supplying storage for the project, the disk that in which we store the data, and we also use it for encrypted storage. So as you know, some of the data is sensitive, so we need to protect it, and we encrypt all the disk, especially containing clinical data and these sort of things. Although we pseudo-anonymize the data when it's in the platform, we take this extra measure as well. The infrastructure manager is a tool that supports the deployment, the automated deployment of the infrastructure and some of the software. EGI DNS is a way to raise the user-friendly names for our components, so we can address them and we can access them in a user-friendly way. So instead of using an address that is complicated and you don't remember, we use a name like data lake lethe.eu, let's say. And finally, we use the Fedcloud client, which is a client that we developed to support the any activities, any task done on the cloud, on our cloud. So this is basically a summary, and you can see here a picture of how these services apply within the infrastructure. So this shows the architecture of the system, simplified, of course. We have the study participants on the left, and they use Fitbit or a mobile device, a mobile application to join and to deliver data to the system. Then this data is stored in the data lake. The data lake is in charge of storing raw data, let's say, so unstructured data. So as accurate as possible to the source that was created. So let's say that there is no data manipulation at this stage. Then we move the data to the data warehouse, which is the core of the system. And this is a structured database, basically, that deals with, collects all the data and presents it to the rest of the components for the analysis, like the prediction and other AI models, so they can use data collected in the data warehouse. And then this is also presented to the dashboard that is used by clinicians. And we have the social robot and the smart glasses. Underneath all of this, we have a set of virtual machines, so servers that run applications, and this is what is depicted there. So you can see that the cloud compute is in charge of providing these servers. The online storage is in charge of providing the data, the disk for storing the data. Check-in is represented by these logs along the figure that represents the security or the authorization or authenticated access to resources. So as you can see, there is authentication when the study participant, for example, enters something, or even between components. So when the data lake wants to communicate with the data warehouse, they also have to comply with some security measures. And the infrastructure manager is used to deploy all this infrastructure, to help us deploy this. And I will spend more time on this. Next slide, please. So this is the summary of the deployment. So I divided this into different ways. The first one on the left is when the Lethe developers publish something or want to deploy something. So on one side, on the left side, we have the mobile application, and they use the Google storage to do that. So the market, and they put it in a way that the client can then download the application and use it in their own benefit. And then we have the other way, the other flow that goes through GitLab. That is when we publish the source code and also container images that we install in the servers, in the backend. So we have these two flows of deployment of applications. One is for the mobile applications that are using Google, and because we use Android in the project, and then GitLab that we use to deploy things in our internal servers. On the right side, we can see how the infrastructure manager and other components install the whole application or the whole, let's say, infrastructure of Lethe. So the infrastructure manager on the left uses some infrastructure templates. And this is a very important point because we code our infrastructure. It's not something that we run by my knowledge, let's say. So I go to the machine and start running commands that nobody knows. So we document all the infrastructure in templates. And this has many advantages that I will tell you about in a second. But basically what we do is we collect a template and we instruct the infrastructure manager. We want this number of servers. We want to have this application. And the infrastructure manager makes sure that these virtual machines that are represented in the image are created. It also raised please go back. It also raised the names of the things. And as you can see, there is another flow on the bottom right. And it's when developers want to do a software update. So they send the code, the applications to GitLab. We create a container image that is stored in a container repository, and using containers and some software templates and Ansible, we install the application in each of the servers. So as you can see, the whole thing is automated. So we have everything documented in templates, so we can treat the template as software, a software component or artifact, and then we can automate the whole infrastructure meaning that we can recreate the whole Lethe platform in a matter of seconds, let's say, or minutes, I would say, not seconds. But the only task that requires more time is the encrypted disk, because normally we do a process that takes a lot of time to create the encryption. But for the rest, we can recreate the whole infrastructure very easily in an automated way. Next, please. So as I said, we are using templates for managing our infrastructure, and those are some of the benefits of using it. The infrastructure is documented and managed as code, so we can use a version control system to know when the change is done. We can recreate things. We can automate the process, so we reduce the disk and minimize the error coming from humans. So I can make a mistake, but by using the templates, I'm sure that is proved, has been proved, and is tested against errors. It's a repeatable process, so there is no user bottleneck. So let's say I'm going on holidays and someone can take over me because the template is all that is needed. You just run the command on the template and the infrastructure is created. So I don't need to remember if I did this operation or this task on this component or this another. So it's all documented. And then efficiency, because the infrastructure can be created in a matter of minutes because we run the process and create the whole infrastructure. So finally, I'm going to give you an overview of basically a little example of how we do this in the infrastructure manager with a Tosca template. And then I will give you another example of how we do it to mount an encrypted volume. But those are just for your information. Is nothing that you need really to pay much attention, but it's just to give you an overview. So you can see here, this is a Tosca template. So this is how it looks, our infrastructure in code, let's say. So it's a YAML file that, in this case, for example, is shown how the ports are open in the infrastructure. So we can say, okay, I want port 22, 80, and 443 to be open in the infrastructure. So these are communication channels that we open for the machine. And you can see that we can change it as if it was code. So we don't need to remember all of this. We just document this in the template and we can run it. Next, please. We can go quickly through this because it's not that important. So this is how I add a SSH key so I can access the machine later. Then in the next slide, we can see how we register the DNS. So in this case, we are registering data warehouse at Lethe Fedcloud.eu, and this is done automatically when the machine is created. Automatically, we assign this name. So from this point, we can refer to the machine with this name, and we can work out the rest of the installation can work out based on this name. So we don't need to remember. In the cloud, it's very typical that when you create a machine, you get some address to access the machine. But if you recreate the machine, you will get a different address. So this minimizes this impact. So by using this name, it's always the same name, and we always address the machine in the same terms. And finally, I think this is how we create a Kubernetes cluster configuration. You can see here how easy it is for us to change this configuration. So at the moment, we have a front end, a control plane that we, by default, or we are using 4 CPUs for it, and we are using 16 gigabytes of RAM for it. So you can see it's very easy for us to change this value, and we can automatically assign, let's say, 8 CPUs to the machine. We run the code and it creates a machine automatically for you with that. So it's as simple as changing this with a text editor, changing this value 4 by 8, 16, 32, something like that. And then infrastructure manager, we make sure that the machine is created for us. So I think this is all. Okay, this is the final command that I need to run. So I run this IAM client create, and I pass the template. And once this is created, you can see below in the graphical user interface, like the web interface that the infrastructure manager provides, that the application has been created. This could be similar to the second row that you see, that there are 4 machines on the right side, 0, 1, 2, 3. So those represent machines that were created in the infrastructure that can be used and configured in a Kubernetes cluster, let's say. So this is the example. And finally, I have another example for you that is using Ansible to mount a volume with using the Fedcloud client. This is, again, a template for this. So everything, as you see, is documented. This is a typical Ansible playbook. If you go next, you can see that we run commands using the Fedcloud client to create infrastructure in OpenStack. At the beginning, we just check what is the IP address of the machine because we need to operate or do some task on it. So we find the IP address, then we use Fedcloud to mount the disk. And you can see that we run also some OpenStack, some cloud commands to get the volume up and ready. And we attach the volume to the VM, so the volume is assigned to, a volume is just a disk for data. So we create the disk of data, and then we create the machine, and we attach them together. So we say the machine can use this data. This is basically what this is doing. And the last slide, I think, is the execution of this, and you can see how this executes. So I run the command with the template, and then start collecting the IP address of the machine. Then it collects the name of the machine. And finally, in the last slide, I think we just mount the volume. In this case, we got also an error because the volume was already mounted. We just a test, but you see the idea. So by using templates, what we were able to do is to create this infrastructure automatically for us, and we can manage this with a version control system and see how the template works. And I think that's it from my side. Thank you very much.
Thank you very much, Nacho, for your presentation. And I would actually like to call back all of the participants, all of the speakers now, if that's possible, just for a couple of questions for the panel discussion. So if you could turn on your cameras, that would be great. And we will have a brief discussion. So my first question is actually for Hans. And that is in your presentation, we saw a couple of screenshots from the Lethe app highlighting, what we're doing and how in its current state. I saw the screenshots were actually currently in English. So my question is English a requirement for the participants in the study?
No. So we have used English for the development, and we have set up everything in English, and then the clinical centers translated all the content in their languages, and the participants have to be proficient in their language, so to say. So in total, we have 5 languages available in the Lethe app: English, German, Italian, Swedish, and Finnish.
Okay, that's great. And are the participants actually using the app at the moment? Do you have any results with regards to usage, usability, for example?
Yeah. So we have looked at the usage. So we are tracking each step they are taking in the Lethe app. So what screens are the most interesting ones, for example. And for the intervention group, after 6 months, we have a usage rate of 50% daily. So 50% of each participants are using the app daily. And for the control group, it is slightly lower due to the fact that they have not so vast features. There we have a usage rate of 27% daily usage.
Perfect. Thank you very much, Hannes. And then I'm going to move on to Vasilis for a question about your intervention today. So thank you very much. What I would like to know is how difficult is it to maintain the Lethe system? So especially with what we saw, there was so many different components and lots of data. So how difficult is it to maintain it?
Yeah, thank you for the question. Normally, it would be quite hard, to be honest, to design and implement and maintain a system like this. But on the other hand, we have taken all measures that we can find available to build the system into the direction of easing ourselves and potential prospective applications of the system. So we have built it on modern technologies like Kubernetes, and it supports fully containerization, which allows us to manage the various components such as the data collection, the processing, and the storage efficiently. Using containers, it makes it easy to deploy, scale, and update the different services independently with nearly no downtime. And our secure APIs and cloud-based infrastructure that Nacho previously described also make scaling and maintaining the system smoother, even as more participants could potentially join the study, not this one, but for future applications.
Thanks, Vasilis. And also, but you mentioned that so we're collecting data in the project from various different devices. How do you ensure that the data is consistent across all participants, for example?
Yeah, well, it's a fair concern. And as we saw, we collect data from wearable devices like Fitbit, the mobile application, the radar-based, the Lethe App, and cognitive training tools, the CCOG, the CTrain. So that's a lot of information, a lot of different data sources. And also the data is being transmitted in near real time to the data lake and so on, where it is structured and organized to being sent to the final committing place, the data warehouse. Nevertheless, this prototyping pipeline ensures that all participants' data, when it's there, when it's available, is handled in a uniform way and remains consistent regardless of the data source.
Okay, thank you very much. There's quite a big challenge there, but it sounds like you are doing a very good job. Okay, let's move on to Nacho. I have a question for you here, because I think one of the big challenges of all or most EU-funded research projects is what happens afterwards. So we work for a period of time developing a solution for a specific problem. In our case, a very, very important issue to tackle. But what I would like to know is, from the technical perspective, do you think it will be possible to reuse the Lethe infrastructure in another way? For example, could it be included in a package in a different clinical environment, for example?
Okay, so yes, it's possible to do it, because the tool that I talk about, the infrastructure manager, it's able to use different clouds. So the first thing that if someone wants to create this whole or this sort of package with all the infrastructure to run the same simulations and the same things that we did, the first thing they need is to use a cloud. It could be Amazon, it could be Google, it could be the EGI Federation in one of the national providers. So that's possible. So with this step, the next thing is that they need to use the templates that I talk about. And by using the templates and the infrastructure manager is a tool that is open source and can be used for free, let's say. So they can use our templates to recreate this infrastructure in another environment. So there is no package as such. So it's not something that we have developed in a way that you can just click and install, but it's close to that. So the problem is that the infrastructure, as Vasilis said, is quite complex. So we have a lot of components, and we have the architecture is not an easy click and install, but it's close to that. So by using the templates and following some steps, it can be recreated. So some other institutions, some other research center can run the same clinical analysis with another study participants, for example. So yeah, that is feasible.
That's good to hear, and I'm sure it's something we'll also be focusing on towards in this last stretch of the project as well. This kind of continuity, the sustainability. But keeping on with you, Nacho, you mentioned again the technical infrastructure. How has it evolved during the project?
The infrastructure.
Yeah.
So we have we can say that it evolved in two aspects. So the first one is that when we initially planned the project, we foreseen to use different technologies. But as we studied how we implement what we want to do, we discovered that these technologies are not appropriate for what we wanted to do. So we changed a bit the schema. For example, initially there was no plan to use Kubernetes, as we saw that we use Kubernetes in some of the components. So this was out of the initial plan, and we evolved the platform to adapt to more modern technologies that initially stated, and to go with the recent advances in IT. So this is one thing, and the other way that the infrastructure evolved is because, as I showed in my presentation, there were some hardware requirements, and this evolved during the project. So initially, sometimes we planned, for example, to use two machines, two servers, to run some applications, and we saw that it would be more beneficial to use for example. So we changed the specifications of the platform, let's say, or the infrastructure, adding new nodes, new servers, new RAM, new CPU. So all of these have to be or has evolved during the project. So this is basically the 2 points where the infrastructure evolved.
Thank you so much, Nacho. That's great. And actually, with your answer there, we come to the end of my questions. Over the past couple of weeks in the promotion of the webinar, we've collected some questions from participants on social media. And also there's been a question in the chat today as well. So I just have a couple more questions, but these are coming from the audience. So first of all, I would think I'm going to target Vasilis. And Vasilis, a question for you that we have that's come through, and that's how do you ensure participants stay engaged with the data collection process?
Yeah, that's a really nice question, isn't it? So the two main factors that we see that highly affect the clinical trial could be adherence and engagement, right? So during the trial, you need to do your best to keep the patients within the trial and also keep them engaged to what they're supposed to be doing. So while sometimes there are only some things that you can do to control that, at the Lethe project, we have a serious look at that issue and we try our best to keep them motivated. And as we saw, we provide the personalized feedback through the Lethe app. So each week participant receives some scores and also some motivational messages based on their data, based on their achievements, and based on their behavior the previous week, which helps them understand their progress and encourages them to stay involved. If, on the other hand, someone's engagement drops, then the app sends some reminders to help them get back on track. So despite the challenges, our goal is to make the experience as engaging and as supportive as possible. And I believe we are at a really good stage of achieving that. Also being a guideline for other projects to implement things of keeping patients motivated.
Thanks, Vasilis. And I know that's an extremely difficult task. We have a question in the chat, and that is, are the study participants at risk of dementia or already have MCI or dementia? So maybe Hannes, you can take that.
Yeah, sure. So our participants are at risk of cognitive decline, but they have no MCI or dementia. So they are only at risk, and this is also assessed by the CAIDE risk score. So the cardiovascular risk factors, aging, and incidence of dementia. And yeah, that score includes, for example, the age, sex, education, the blood pressure, and so on.
Thank you very much. And I think we'll stay with you with another question that we've had come through. And that was, what challenges are you expecting regarding the training of the AI models for the data you're collecting?
What challenges we are expecting? So it is a lot of data and from many different data sources. So as we have heard in the presentations, the Fitbit data we have, that is a lot we were collecting and are also aggregating right now, and also find appropriate timescales for every variable, for example, because we have continuous variables like the blood pressure, which they can enter in the app, but we also have fixed time points with the visits where we collect data. And it's a big challenge also to try to harmonize them all together into one model. I think that is a challenge which we are currently facing now.
Thank you very much. And we just actually had another question come in through the chat, and that's, there's various apps there are apps targeting other diseases. Would it be a problem for the sustainability of the Lethe app? For example, people using too many different health apps? I'm not sure if anyone would venture an answer here. Hane or Nacho? I think here we're kind of aiming at kind of the saturation perhaps of the market of this type of apps, but
yeah. So what we are trying to do with the Lethe app is with tracking. So we are a feasibility trial, so we are looking into it. Does it work or not. And one goal we are also trying while developing is that we really track each feature and then look at the features which are mostly used and then focus on that in the future. So we really try to tailor the applications to the people, and also while we are developing the app, older adults have some specific needs when they are using the app, and we really try to get them engaged also, as Vasily said, and then concentrate on these features they are really using.
Thank you very much, Hannes. Right, I think we're running out of time, so I think we're going to conclude there with the questions. What I would like to do is just 1 second. So just show my screen. Here we go. Just really say a huge thank you to, firstly, to the audience. Thank you for coming today. Thank you for your questions. Thank you very much to all the back office team who've been helping to prepare the webinar, and thank you obviously to our speakers for your interesting interventions. It's been great to have you here today. What I would like to say is that this is the first in a series of webinars. We do have another one planned for the 13th of December, Friday the 13th of December at the same time. And in that webinar, we'll be now moving perhaps away from the technical side of things and having a look at the clinical side. So looking at the pilots that we're carrying out in the Lethe project. So we invite you to join that webinar for another interesting discussion. But until then, thank you very much. You'll be able to find the recording of the webinar on the Lethe website. And also, please feel free to reach out to any of the project team for information about the project itself, or on our project website, where you can also find the latest updates, events, activities being carried out by the project team. So without further ado, I'd like to say thank you. Have a great Friday, and we look forward to seeing you again next time. Thank you very much, everybody.
Thank you very much. Have a nice weekend.